Hello, in this video I'm going to do some more examples of derivations that have a premise that is a complex negation. So in this case, we're going to try to show the conclusion, and the conclusion is negation Q. Okay, so we'll make an assumption for indirect derivation. We always want to make an assumption. We can't do assume CD because we're not trying to show a conditional. So we'll do assume ID instead. Okay, good. Now let's pop in our premises. There they all are. Okay, so well, can we apply elimination rules? No, because we don't have anything to apply elimination rules to. 2 and 4 are atomic sentences. 3 is a complex sentence, but there's a conjunction in it, but it's not a conjunction, it's the negation of a conjunction. So simplification does not apply, because simplification applies only to conjunctions and not to negations of conjunctions. It's a negation, so we have the D&E rule, but D&E only applies when you have 2 negations, and we only have 1. Okay. So what we have is one of these negated premises. And when we have a negated premise, what do we want to do with it? Well, if we had the unnegation, we could apply ID and we could complete the derivation. So we have a complex negation on line 3. Having trouble typing. So we want to get So there's that complex negation on line 3. And what do we want to do with complex negations? Well, we want to get their unnegation. So we want the unnegation of line 3, because then, although we don't have any inference rules that apply, we do have our boxing and canceling rules, and in particular we can apply ID. So that's what we want to do. We want to get the unnegation. So what is the unnegation? The unnegation is P and Q. Okay, so how do you get P and Q? Well, one way is to build it. And how do you build it? You use the rule adjunction applied to P and to Q. Oh, well, look, that's what we have. We have on line 4 we have P, and on line 2 we have Q. So you can say 4 to ADJ to build the conjunction. And we want to choose the negation of 3, so we want P and Q, which has helpfully been selected for us already in this case. So we'll click OK, and there we have 5 and 3, the negations of one another. So we can say 3, 5, ID. There we go, we're done. Once we figured out, oh, well, it's indirect land, I'm in indirect derivation land, I can apply ID. Well, so let me get the unnegation of this, which is... Right, I want the unnegation of that, and the unnegation of that is this. And how can I get this? Well, I can apply ADJ to P and Q, which I fortunately already have. So I'm done. So good. Hooray. Let's take a look at another problem. All right. So, show conclusion. Negation of if Q then P. So can you get to if Q then P, or from P to Q? Can you get from Q to P? No, you can't. If Q is true, it does not follow that P is true. Good, so we should make an assumption, because we always want to make an assumption. Now, can we say assume CD? No, because line 3 is not line 1 is not a conditional. Line 1 is a negation. It's a negation of a conditional, but it's a conditional, right? We do assume CD when we're trying to show a conditional, when we're trying to say you can get from Q to P, but we're not trying to do that when we're trying to show negation of if Q then P. We're actually saying, among other things, you cannot go from Q to P. So a conditional assumption would be entirely out of place. So instead we should say assume ID. And there's if Q then P. Good. So now let's pop in our premises. So we have if Q then P, we have negation of P if and only if Q, and we have if P then Q. Okay. So in this case, we do have some complex sentences, lines 2 and 4. So for MP with line 2, we would need Q, and for MP with line 4, we would need P. For MT with line 2, we need negation P. For MT with line 4, we need negation Q. We don't have any of those, so we can't do MP or MT. What about line 3? Well, line 3 is the negation of a biconditional. If it was a biconditional, we could apply BC, but it's not. It's the negation of a biconditional, and BC does not apply to line 3. What else can you do with line 3? Well, if we could get its unnegation, we could apply ID. What is the unnegation of line 3? It's the biconditional P if and only if Q. 3 is that whole thing. That is the unnegation. So that's what we would like to get. Can we get that? Yes, we can, because to build the biconditional, we apply the rule CB to put two conditionals together to get the biconditional, and that's what we have on lines 4 and 2. So we can say 4, 2, CB, and let's make sure we choose P if and only if Q. And again, we have a contradiction between 3 and 5, so we'll say 3, 5, ID. Same old thing, right? When you have the complex negation, get its unnegation and apply ID. The unnegation is P if and only if Q, and we had what we needed to build it right away. So we'll look at one more, actually no, this will be the end of this video, and we'll look at one more problem in another video. It's a little bit, somewhat more complex version of this same kind of problem.